Hello and welcome to this lecture on the DPSIR framework. My name is Nadine Meyer. I'm from the Institute for Analytical Research at the Fresenius University of Applied Sciences in Germany. First, let's have a look at our agenda today. We will discuss what DPSIR means, and I will show you several application examples. Also, we will have a look at the benefits and the critiques and limitations of this framework, and then look at modified and related frameworks. What is DPSIR? DPSIR is a framework for analyzing the interactions between human activities and the environment and developing strategies to improve environmental quality. That said, it's not a set of hard and fast rules, but a guideline for tackling such analysis. DPSIR stands for drivers, pressures, state, impact, and responses. On the figure, you can see how they are related to each other. Drivers. Those are factors driving the environmental changes, for example, population growth or tourism. These can cause pressures on the environment, so, for example, pollution. The pressures have an effect on the state of the environment. This can be water quality or air quality. Those conditions have an impact on humans and the ecosystem, so like health issues or the loss of biodiversity. To counteract those, policies and regulations to improve the situation can be implemented as a response. And this, in return, will have an impact on drivers, pressures, and the state. So you can see all elements of the DPSIR framework are related to each other. Let's have a look at the history of frameworks describing interactions between society and the environment. The roots go back to 1979 with the stress response framework. Later on, in the 90s, the pressure state response framework was developed by the OECD. This framework focuses on human-made effects, not taking natural variability into account. So in 1997, the driving force state response framework was established. In this framework, the pressures are replaced by driving force. This includes social, political, economic, demographic, and natural pressures on the system. But it somewhat ignores reasons for those pressures. So the European Environment Agency developed the DPSIR framework as we know it. Drivers and pressures were separated, and it also introduced impact as motivation for the responses. So what is DPSIR used for? You can use it for structuring and understanding the links between human pressures and state changes in the environment. It is also helping researchers and decision makers to identify causal pathways and design effective responses. Basically, you can use DPSIR every time you want to assess the effect of humans on the environment or vice versa. Application examples could be the monitoring of reforestation efforts or the regulation of pollutants like PFAS. Can also be used to improve the management of water resources or the investigation of marine and coastal ecosystems. Because there is such a variety of topics, we will focus on the investigation of marine and coastal ecosystems. What does the application of the DPSIR framework to an environmental analysis look like? I brought you two examples for studies related to the marine environment. One focuses on the coastal region, one focuses on beaches. Let's start with the analysis of the coastal environment in Italy from 2002. In this table, you can see the DPSIR elements and the components the authors identified. I'm not going to address each point of the components, but we'll have a look at some of them. As drivers, we have resident population, distribution of GDP, and tourism. Then we are looking for measurable indicators for those components. For the resident population, this can be the population itself or the density of the population. As for tourism, for example, the number of annual tourists or the ratio of a resident population. For pressures, we have land use, which can be measured in percentage of each sector. Also, employment distribution or nutrient loads, maritime transport, and fishery. Each of these components has its own indicator. For the state, physical-chemical parameters were used for the trophic index. The identified impacts was mainly the quality or availability of bathing water. And for the responses, depuration budget, wastewater registers, distribution of discharges, and marine protected areas were addressed. Something you should keep in mind is where you actually get your data from. In this case, quite a lot of data was collected from public databases. This can be information provided by the state or municipality. There's also private databases if you need information from specific companies, for example. Data on the water quality can be collected from scientific literature or good old fieldwork if you need to collect the data yourself. Our next application example is much more recent. The DPSIR analysis of beach pollution in Tuscany, Italy from 2022. This study focuses not so much on water quality as the previous study did, but on the beaches. Some components are comparable to the other study. As we can see, for the drivers, we also have resident population and tourism. The authors also took weather conditions like daily rainfall and water circulations into consideration, as pressures, waste, and emissions, as well as maritime activities and transport, were identified. The state of the shoreline was characterized by physical features, like the quantity of the material washed ashore, as well as microbial pollution, like fecal bacteria. The impacts are ecological, as in what animals live in the sand, human health, as we all know, fecal bacteria are a considered health risk, and economic in nature, as the material needs to be collected. The responses contain the reduction of solid waste production, control of riverine litter input, and treatment of the stranded material. For this study, over 5 years, material was collected on 4.8 kilometers of sandy beaches. We are talking about 7,000 tons of material per year. The treatment of the collected material is outlined in this figure. First, the material needs to be separated from the sand with sand recovery rates of about 50%. The residual material is then sorted manually to filter out any compostable material, the green fraction, which is about 30%. The leftover anthropogenic waste is collected in a landfill. After evaporation of the water, this only makes up 3% of the stranded material, making this a very successful but also cost-intensive treatment plan. Our next example is not a published study, but an exercise on how to apply the DPSIR framework on the analysis of the marine ecosystem of the Annelic volcanic arc. Remember, the DPSIR framework is not a set of rules, but a guideline. There are no right or wrong answers. You can pause the video if you like to think about the components of each element. Here is what I came up with. Drivers: tourism development, fisheries, urbanization, and climate change. The Hellenic volcanic arc is a popular tourist destination, but increased tourism leads to habitat alteration and pollution. Overfishing and unsustainable fishing practices impact the marine biodiversity and fish populations. Also, habitat destruction and pollution stemming from expanding urban areas and settlements on the islands can affect the marine environment. And rising sea temperatures, ocean acidification, and changing ocean currents are potential threats to marine ecosystems crucial for various marine species. Now for the pressures. Those are pollution, overfishing, marine traffic, and tourism infrastructure. Coastal development increases wastewater discharge into the sea, which can lead to nutrient loading and thus harmful algal blooms. Intense fishing activities deplete fish stocks and disrupt trophic structures within the marine ecosystem. And increased marine traffic, including ferries and cruise ships, contributes to risk of oil spills, noise pollution, and physical damage to sensitive marine habitats. The construction of hotels, marinas, and other tourism infrastructure can lead to coastal habitat destruction. The state can be characterized by biodiversity loss and water quality. Changes in species composition, including declines in native fish species and other marine fauna resulting from overfishing and habitat degradation, lead to a biodiversity loss. Altered water quality due to pollution can lead to hypoxic conditions and toxic blooms that affect marine life and human health. Impacts are the decline in fisheries, loss of ecosystem services, and health risks. Reduced fish populations lead to economic impacts on local communities reliant on fishing for their livelihoods. And the declining marine biodiversity affects ecosystem services such as carbon sequestration, coastal protection, and recreational opportunities. Increased pollution may also affect public health, with potential risks to those engaged in recreational activities and fisheries. And possible responses to those impacts may be marine protected areas, sustainable fishing regulations, pollution control measures, community engagement, and research and monitoring. The establishment of marine protected areas may protect key habitats and biodiversity by limiting fishing and tourism activities in sensitive areas. The implementation of catch limits, seasonal closures, and improved fishery management practices may ensure sustainable use of marine resources. Strengthening the regulations for wastewater treatment and marine traffic may reduce the pollution entering the marine ecosystem. It is important to involve local communities in conservation efforts and promoting sustainable tourism practices to enhance local stewardship. And finally, conducting ongoing research and monitoring of the marine ecosystem will provide data for informed decision-making and adaptive management. So there are quite a lot of use cases for the DPSIR framework. DPSIR provides us with a systematic approach for identifying and categorizing environmental problems, so you can break down those challenges into discrete components, as we talked about before. It facilitates a clear understanding of those relationships. Because it is taking ecological, social, and economic factors into account, DPSIR encourages a comprehensive view on environmental issues. It can help to recognize how different components interact with each other and improve the analysis of these complex systems. With the DPSIR framework, linkages can be identified by outlining the relationship between various drivers, pressures, states, impact, and the responses. This is very helpful for diagnosing problems and determining effective interventions to solve these problems. This framework also supports adaptive management approaches. It allows continuous monitoring of environmental changes, evaluating responses, and adjusting management strategies if needed. The DPSIR framework is also very flexible, as it can be adapted to a variety of contexts, including different geographical location and types of environmental issues. DPSIR can help to raise public awareness and engagement by framing environmental issues clearly. This way, it makes it easier for stakeholders and also community members to understand the complexities of environmental challenges and the rationale behind management decisions. This framework can also provide the foundation for developing environmental policies and strategies. It provides a structured overview of issues at hand, allowing policymakers to design targeted and effective interventions. But of course, there are also limitations to this framework. As we have seen, the framework does not have a clear set of categories. This leads to inconsistencies and challenges if you want to compare different studies to each other. For example, climate change can be viewed either as a driver or a pressure, and this can create confusion with categorization. This ambiguity can hinder effective communication between researchers, stakeholders, and policymakers. As we are working with very complex systems, this framework tends to oversimplify interactions among its categories. An impact can arise from multiple state conditions or responses, but the DPSIR framework does not address these synergies. This oversimplification may lead to misunderstandings about the dynamics of environmental problems. The framework has also been criticized for not clearly illustrating causal relationships behind environmental issues. This lack of clarity can stem from varying interpretations, misunderstandings, and insufficient knowledge about the systems being analyzed. Because DPSIR was originally conceived as a conceptual tool, the framework does not encourage the inclusion of locally specific attributes. This can lead to a disconnect between analyses and actual local conditions, resulting in ineffective or misdirected sustainability efforts. The DPSIR framework does not explicitly address the relationships between developers and developing communities. Developers in this case can be non-governmental organizations and other international organizations. This dynamic can disregard local knowledge and limit the effectiveness of the responses. In principle, this framework does not prioritize or evaluate the effectiveness of each response to environmental challenges. These limitations led to the development of other frameworks. As you can see in this graph, which covers the use of DPSIR and related frameworks in the context of marine and coastal environments. As you can see, DPSIR has been used a lot, but depending on the focus and need of each study, the framework has been modified. Those modifications include driver pressure state welfare response, which focuses on the human welfare, differential DPSIR, which also takes the changes in drivers, pressures, and impacts after the implementation of responses into account. And there is DPSIR or DPSI-WORM, which stands for drivers, activities, pressures, state change, impacts on human welfare, and responses using measures. In this instance, driver refers to the basic human needs like food, shelter, and security. To obtain these, societies carries out activities like fishing or building. And those activities then create pressures. In the EU, responses are referred to as measures, so hence the term response using measures. The DPSIR framework can also be used as a nested approach for the evaluation across ecosystem boundaries or over time. The DPSIR framework can also be combined with other frameworks, such as MCDM, which stands for Multiple Criteria Decision Making, AHP, Analytic Hierarchy Process, or the Tobit model. Those combinations have been used in a variety of cases, which you can see here. I hope you enjoyed this short introduction to the DPSIR framework, and I thank you for your attention. Bye!